Hello, and welcome to this session from Tecton on feature engineering at scale. We're really excited to dive in and really engage with the larger Arize community. So thanks so much for joining today's session. Just a quick run through of what I will cover today. So just going to power through a couple of kind of slides really just for context before we dive into kind of what I would consider to be the fun part of the session today. So just going to really walk through kind of how we help our customers to really make real-time machine learning a reality within the products that you're building for your customers. We'll kind of run through the concepts of the feature platform and what really helps to underpin a lot of these. And then really primarily today's demo will be focused around notebook development, but we'll give kind of a run through of the overall feature platform in that context as well. So let's dive right in. So real-time machine learning is something that we're hearing more and more of our customers. And in fact, we have a survey report coming out soon that really indicates that this is a huge trend that our customers are really looking to implement within their products. So I think a really helpful kind of canonical example here is Uber Eats, right? So this is very relevant to Tecton and our customers because this is really the first sort of the seed of what became our feature platform was Uber Michelangelo, built in-house within Uber by our founders. And then eventually, over time has evolved into, its own company and really its own feature platform. So in this context of Uber Eats, I think it's really helpful to think about, this ETA example, right? So 20 to 30 minutes total estimated time is the prediction that's being given here, and there are many things that go into producing that number. It's not just sort of an arbitrary static number. It's very much a constantly changing prediction based on many things. So what goes into that example is all of these many raw data sources like live deliveries, driver locations, restaurant orders, etc. These are all the data sources that are fed into what become the machine learning features such as restaurant order count, available drivers count over a 5-minute span. And all of these features really help to drive a more accurate model for these predictions that are visible to the end user in real-time products. So in this example, you can see again that ultimately gives this fairly precise range, whereas I think we can kind of think back to a different era where you would sort of call a pizza place and they would just give you the same number regardless of your circumstances and say maybe we'll probably get there. We can promise probably within an hour, maybe an hour and a half. And in this case, it's able to drive very precise predictions. So, very much something that our customers are looking to achieve. And the reality of the situation is, building these real-time ML systems is very challenging. And then on top of that, maintaining them is that much more difficult, right? So, as far as what goes into it, it's, the outcome of this is you end up with really siloed, kind of error prone and brittle systems, difficulties of scaling, expenses of building, maintaining, and managing these systems. And the outcome, that you're really, looking to drive to, like these use cases that we'll touch on a little bit later, recommendation engines, fraud detection, dynamic pricing, in these data sources, it's really kind of this, really intricate set of interrelated systems that can tend to be really challenging to maintain. So that's really where the concept of a dedicated feature platform comes into play. So we're really focused here at Tecton at allowing teams to really quickly and reliably transform and serve data for ML applications. So this is a look at kind of the sort of the, what we enable our customers to do. I'll show kind of some of the platform architecture in the next slide. But a lot of these real-time data sources that we're looking at here really help to drive and inform a lot of these calculations that we showed that really underpin this real-time ML pipeline that we showed here at the beginning. So as we think about, this being a really critical data source, also, of course, streaming data, batch data, and this is really even an ever-expanding list. So this is kind of our list today, but lots more to come in that arena. And then really, ultimately, we're allowing our customers to build and iterate a lot faster, centralized and standardized ML data, monitor and control those costs. And you could be powering just one or even sort of thousands of models simultaneously. And ultimately, that through the Tekton API, you're really allowing for online inference or Tekton SDK offline training. And a lot of the compute and storage that I'll kind of show in the scope of today's demo, like Databricks, Snowflake, EMR, GCP, would help to underpin a lot of these things. So yeah, so that was kind of the sort of the process by which you achieve it. This is the actual sort of platform architecture that underpins that. So the same concepts of data sources, compute and storage, and online inference and offline training that are all interconnected here. Within the feature platform, there's the feature engine, which drives the transformations, the feature repository, which really allows for integrating in with your GitOps workflow and better feature sharing across. And then the feature store, which we'll show really in the scope of the demo of what that really means concretely, but really what Tekton is really best known for from the start, and what was kind of spun out of that Uber use case that I showed at the beginning. Feature management, and then of course feature logic, really allowing you to make constant iterations and improvements to how your features really inform a more accurate set of models for your end user. So ultimately, we have many customers that use Tekton today. Just highlighting a couple here, like Plaid, Atlassian, FanDuel, Shopify. So really pretty diverse set of industries: finance, insurance, gaming, as well, e-commerce, and others. And a lot of the most common real-time ML use cases that we see our customers really putting to use, our feature platform to use for, are fraud prevention, recommendation engines, real-time loan approvals, ranking and search, dynamic pricing, personalization. Really a much longer list than this, but you can imagine that we're really fairly use case agnostic, but I just want to highlight a couple of the key examples here. So yeah, most recently in the last couple of weeks, or by the time this airs, sort of in the last couple of months, Tekton rolled out the latest version of our SDK, which is 0.6. And a lot of the really core capabilities that come into play here are notebook development, stream ingest API, stream feature review, continuous mode, new aggregations, ACL, CLI commands, query debugging tree. A lot of things that really help, especially towards the feature management end of the spectrum, in terms of how we looked at this overarching view here. Like, we're really not vastly changing anything, and when it comes to feature repo, we really want you to integrate in with your existing GitOps workflow. But also you can see where it slots in. I'll show a diagram in a moment of how the stream ingest API, for example, really helps with the ingest portion of that. And when it comes to notebook development, it's really focused, and this is where kind of a big part of today's demo will be focused around, is we're really helping you to achieve faster model iteration, more efficient feature engineering workflows, the ability to quickly develop and test ML features, and also the aggregation functions that we've added, like first and distinct and last and distinct, really help you to just have these out-of-the-box functions that are that much more readily available, that you're not having to build custom functions into your features. And this is kind of the model iteration loop that comes into play here. So it begins with, of course, just getting everything set up, initial setup of Tekton. Once you're into the feature platform that I'll be demoing in a moment, notebook development really is focused around thinking about how do you develop and test those features before you actually take them into production. So we'll show a little bit of that process in the scope of the demo today. Then generating that training data, productionizing those features, and then sharing and discovering those features is really the model iteration loop that we're helping to accelerate with a lot of these new capabilities that we've released. And then ultimately, the outcome of that is to be able to really access those features online. And really applicable across all of this is, the ability to also monitor these features as you progress, and as you see change, as you make changes to your features and to your models throughout the process, enabling more secure access. I mentioned kind of the access control list being available through command line interface. So within terminal, you can kind of manage user groups in a broader sense, and really also helping to kind of really cut down on expenses as you think about a lot of the expenses that come with building these things in-house versus being able to have a more managed platform that can really help to simplify a lot of your processes around this. So as we think about notebook development and reducing those number of steps for developers that are really creating all of these new features, and here we're showing an example of what that feature definition looks like. So you see batch feature view here. And in this case, we're looking at defining user credit card issuer and setting up a set of select statements where we say, okay, for Amex, Visa, MasterCard, Discover, and all of the appropriate breakouts for each of them, so that we can identify these credit card issues and get a bit more detailed in how this feature definition is set up, and ultimately informing what models really can be made the most accurate. And sort of all throughout, I mean, this is really focused, it's as we looked at in the last portion, really focused primarily in the developing and testing phase. And then sort of the productionization comes later, but it's all towards an end of a faster iteration loop. So cool. So I'll come back to the last couple of slides, but let's switch over to the platform. So this is the Tecton feature platform. You can see here kind of the broader view that you really get of all of your data sources that might be of use or of interest. Here we're looking at a set of, primarily advertising or ad impression data. So we see ad impression batch and streaming data that's made available. The keyword click source, user event source, transaction stream, transaction batch, and users batch. I'll show some visualizations of how this is sort of visible in more of a pipeline. And then here we have all the specific entities. Of course, this can all be changed or updated. But as it's set up today, we're kind of thinking about not just ad data, but also starting to think about how do we sort of tamp down on potential fraudulent scenarios within advertising, as you want to kind of address that you're considering all of the ways in which your advertising data is pointing to, the most relevant data for your customers, and you want to avoid any fraudulent activity. So you're really looking at scenarios where you want to kind of identify maybe bots or kind of misaligned data that indicates something maybe amiss with your data. So you can see the various join keys. So user IDs being used for ads user and fraud user. If we click into this individual entity, we can see the associated feature views for fraud user. We can see user weekend transaction count, 30 days, etc. So this is, it's pivoting out on this individual entity. So we have quite a few feature views that this is attached to. And then really a key part of what, makes this different than if you were kind of building this in-house is you also have the ability to run your transformation. So here we're looking at user transaction aggregates by category and the underpinning code for that. We can see the various transformation modes that are set up. So either PySpark or Spark SQL across the board for each of these. Then let's dive into the features. So really kind of the headliner here. So feature views, we can see a complete list of the feature views that are set up right now and all of the associated features for them. So clicked count, gets very granular, and the feature view or table that's associated with it, as well as whether materialization has already been enabled for this or not. And then as I sort of mentioned in the overarching feature platform view, you also have the ability to monitor your features. So you can basically we're looking at just for prod workspace, the number of feature views and tables. So we see 15 are materialized out of a total of 34, and not a huge set of changes over this time period. So we don't see a big trend line here, but you can imagine ways in which you can kind of help to track and better understand how things have changed from the view of from the perspective of materialization. So you can see the majority, if we look back at last 30 days, the majority of the materialization are really all took place on March 25th, which is when all of this materialization took place. And so you can imagine that this can get a lot more granular if you're looking to really track changes and understand how your team is kind of working collaboratively to make updates to your features. And then here we can see services and then data sets as well, if that's of relevance for your team. So I've already got Databricks loaded up here. which is the platform that the compute that's loaded up here as part of this demo environment. I'm just showing for just completeness sake. This is a different example. I'm just tabbing between where Snowflake here is being used as compute, and then I would just click out and log in and look at the associated data on Snowflake's platform. But just to kind of make it a little bit more tangible that we have the ability to work with various types of compute, and just showing that Databricks and Snowflake are just a couple of examples here. So yeah, let's dive in. So when we look at the Databricks platform and kind of diving into thinking about how notebook development can be achieved from here and be able to really tangibly develop, test, validate your features, I have a couple of examples already loaded into this particular workspace. And so I've already loaded up these parameters here, and I've got basically I've attached it to a cluster. So just to tell you what's kind of already occurred, and I've just broken these down by individual cells. So I just want to show a couple of quick things here. So rather than whether it's in sort of GitHub Atom or showing this within even just like a Jupyter notebook local build, we're doing notebook development within the Databricks platform. If I just run this quick cell, we can get a quick sense of what Tekton version we're on, and then the associated Git commit for that. We can actually pull down remote objects here. So in this case, we're saying I want to, from the production workspace, we're looking back at, you can probably remember that we're looking at fraud user as an example of an entity that was available within the demo environment. So because I've already run this cell, now we've pulled down this remote object from this workspace, and we want to get the specific data source of transaction stream. And you can see before I ran this command, you could see that the table had already loaded of what Spark Jobs had sort of produced this set of data. So we'll let these Spark Jobs run, and kind of once they have, we'll get a better sense of what the output is of importing PySpark SQL functions and then displaying transactions with this associated user ID of 3944, et cetera. So we want to get really granular and specific. If you're looking for kind of that needle in the haystack, it's a really quick way to just like develop or just really test your theories about an individual feature before you actually take it into production. So we'll kind of let these Spark Jobs run in the background, and in the meantime, I'll kind of show you back where the entity was that we were looking at. So again, join key of user ID, fraud user was this particular entity that we're interested in. Then we can see the owner, last updated by, and all the associated feature views for each of them. So as you can see, it's a pretty long, comprehensive list of what is actually, which feature views these are attached to, and the descriptions for each, whether they're batch, et cetera, and then whether materialization is enabled for online and offline. So you can get a pretty good sense here of what you can expect. Also, while I'm here, let me just show within Databricks. We'll pop back open this Databricks example, and then I'll show a little bit different example of a couple different notebooks that would be of interest here. So we can look at a single cell showcase as well here. And this is sort of an older API key attached to it. We can see the outputs already shown here of if we run basically this entire cell collectively, where basically we're saying we want to define and test these objects directly in the notebook, validate these objects directly in the notebook, and then basically show all of the validation of those dependencies and validate these transformations. You can see that output has already occurred. So yeah, so now that this Spark job has taken place, we can see the associated transaction IDs for this user ID. And in this case, none of them are being flagged for fraudulent activity. So kind of no red flags that need to be addressed here, but just a little bit different view into this individual user ID. And then let's jump ahead to the next cell where we're saying we want to define and test these objects directly in a notebook. And essentially, once we've done that, we can start to think about how we want to actually validate and make sure that we're validating each of these dependencies, and then grab that existing feature set from a feature service. So cool. So let me show a little bit different view. Let's jump back into the Snowflake instance that I was showing earlier, and I want to actually go back to features, and let's kind of dive into the pipeline. So here we're looking at user fraud rate sum, and I think this is a good sort of simplified example of where we can see. So let's start with the overview of kind of, there's just an interactive Python example we've included here of that you can use as a reference. And then you can see the features, the feature view or table, the aggregation is the type here, and whether or not materialization has occurred. And then I really want to just show quickly this example of the data flow. So in this case, as I mentioned, this is an example where Snowflake is the dedicated compute for this particular instance. So Tecton demo data.fraud is where this is being pulled down from. Transactions are the source here. User fraud rate sum are the transformations that are occurring, and then we get user fraud rate sum as the set of features, and then is fraud sum all these individual features within that. So just gives a little bit different view of kind of how the pipeline flows in a very logical sense. We can look at a little bit different view of like if we look at a different example for user weekend transaction count 3D over 30 days, we can see there's actually only one feature within this feature service. So we're saying, kind of a similar format, but it shifts into is weekend as the transformation. There's actually two transformations being run here. And then user weekend transaction is the feature service list. And then is weekend sum 30 days, as we mentioned, is the feature that we're focused on here. So just a little bit different view, but we just want to show some of the parallels. Of course, you can expect a lot of similarities on the feature platform side, but then if we jumped into Snowflake, there would be a little bit different process and flow for how you would actually make changes to or shift the types of data sources that are most relevant for your use case. So cool. So let me just jump back into, I want to jump a couple slides and just show very quickly some context for an additional capability we've just rolled out as part of our most recent launch of the feature platform for 0.6 SDK. And the stream ingest API is what I want to focus on here. It really is enabling more low latency ingestion that really is about powering a lot of these real-time machine learning pipelines that I touched on at kind of the beginning of the deck, and really allowing you to store and serve features via the stream ingest API. So you can see here we're really allowing you to bring in that much fresher data for your particular use case. The stream ingest API really helps to enable that more readily. And it's really, we think of it as the simplest way for you to build real-time ML feature pipelines and really send records directly to the feature store through a new HTTP endpoint. And it's really about online feature values being updated really in milliseconds, whereas, previously it would have been sort of a much larger time scale in order to actually make this happen. And the latency would be very apparent, not just for your developers in-house, but also for the end user as they're using kind of real-time predictive products as the end user. And then we're really also enabling automatic backfill from batch sources, as well as Python transformations that will be coming shortly, powered by Tecton's execution environment. And this is really available across many platforms. So would love to hear from you what data sources you're looking to bring in so that we can really help to address and think about what would make the most sense for you. So cool. So with all of that, just really excited to see what folks go out and start building. We're always open to seeing what you are looking to build next, and would love to hear more about that. If you just go to tecton.ai, you can dig into a lot more of what you're looking to really evolve through and think about what use case is most relevant for you. And feel free also to sign up for the free trial straight from Tecton.ai, just up there in the top right corner, and we'll get you set up with a very similar environment as to what was demoed today. So with that, I think we have a couple minutes left here for if you have any questions that you want to pop into chat, and then we'll make sure that those questions are addressed from the Tecton team, whether it's today or in a longer conversation if you'd like to connect for that. So thanks so much for joining today. And again, just tecton.ai is the URL if you'd like to dive right in and learn more about some of the feature platform capabilities that were shown today. Thanks so much.